because we only introduced it previously. So for a simple pendulum, we make a figure. A figure says mass suspended by a string, and then it moves, makes an angle theta. L is the length of the cord, and x is the displacement here. So the components of velocity basically depend on weight. So here's the x component of weight, and here's the y component of weight. Wx is equal to mg cos theta. Okay, let's not write it here, we'll write it on the main region of the page. So Wx is equal to mg cos theta, horizontal component of the weight, and vertical component mg sin theta. Okay, and we also know that x is equal to L theta in the case when this arc makes an angle theta with the chord of length L. X is equal to L theta, so theta is x by L. Okay, so we use this one as a substitution because the force we have is dominated by the vertical component. F is equal to basically ma 1, and then F is equal to the driving force, which is mg sine theta, or minus mg sine theta because of the direction. Okay, so we equate the two. Ma is equal to minus mg sine theta, and a is equal to, m gets cancelled out, so a is equal to minus g sine theta. So there are approximations now because the angle is very close to 0 degrees, so sine theta can be approximated to theta, and also a substitution which says that theta is equal to x by L. So a is equal to minus g theta, and then a is equal to minus g x by L. Yes, so this is 3, and we also know that in oscillatory motions a is equal to minus omega square x. Yes, on the horizontal domain. So we equate the two. Minus omega square x is equal to minus gx by L. X cancels out and minus cancels out, so we get omega square is equal to g by L, which gives us omega is equal to g by L under the root. Okay, and now t is equal to 2 pi by omega. Okay, as omega is equal to 2 pi by t, which we already know, so t is equal to 2 pi by omega. Okay, so now we equate once again, excuse me, so omega is equal to g by L under the root here, number 5, and omega is equal to 2 pi by t. Yes, unit angular velocity is 2 pi by t. So we now equate 2 pi by t with g by L. 2 pi by t is equal to g by L under the root, which says that t is equal to 2 pi by g by L under the root. So we call it 5, and f would be the reciprocal of t, and f would be g by L under the root by 2 pi. I'm not wrong, and this is understandable also for the beginners. Simple harmonic motion and kinetic energy. We have to make a form for it. So Ke basically is equal to 1 by 2 mv square, as we know from mechanics, and B, as we established for SHM, is omega into x naught square minus x square under the root. Okay, where we have this little circle which has a radius r and makes an angle theta. Radius r, angle theta, projections it makes is x and y. The velocity is tangential usually, but we don't go into that detail. We simply take this r, the radius, the theta here, the x here, and the y here, the triangle. Okay, r is in totality x naught, but it changes its values. Anyways, Ke basically is equal to 1 by 2 m into omega square into x naught square minus x square here. So A is equal to minus K by m into x, that we know, as established previously, and also A is equal to minus omega square x. So pretty simple. If we compare these two, let's say A and B, and for example this is 1, so comparing A and B, okay, minus K by m into x is equal to minus omega square x. X cancels out, omega square and also minus is cancels out. Omega square is equal to K by m, so omega is equal to K by m under the root. Okay, so we now put the value, the form of omega into the form 1, equation 1, and substitution of omega. Yes, so Ke is equal to 1 by 2 m K by m x naught square minus x square. M cancels out, so Ke becomes equal to 1 by 2 K x naught square minus x square. So this is the form we are looking for. Yes, so r can be approximated to x naught, and then this can take further form as 1 by 2, where r is the radius in this triangle, 1 by 2 K r square minus x square. Yes, so yes, so this is the situation. overall. Waves is the topic and Doppler's effect is what we are looking into. Okay, so in this situation we have to keep in mind the source of the sound which produces the waves, and then the distance from the